Le Chatelier's principle is an important rule when working with equilibrium and reversible reactions. Reversible reactions occur when the products can decompose back into reactants even after the reactants have reacted together. This happens until both the forward and reverse rates are equal in speed and the reaction has reached equilibrium. When the reaction has reached equilibrium, there are stresses that can cause it to shift right or left depending on the stress. That is essentially Le Chatelier's principle. A system experiences disturbances, such as change in concentration, pressure, or temperature, that cause it to respond to restore a new equilibrium state. The first example explains the effect of concentration on an equilibrium reaction. When the concentration of a reactant in the forward reactant is increased, the equilibrium will shift to the product side to compensate. Think of a reaction as a seesaw. When the reactant side of the seesaw gets pulled down because of the increased concentration, the equilibrium needs to shift right to make both sides even. Another example is with change in temperature. This is similar to the concentration example, with increased temperature causing the equilibrium to shift to the opposite side. But watch out for whether the equation is endothermic or exothermic. If the equation is endothermic, the heat will be on the left side of the equation, whereas if it is exothermic, the heat will be on the right. This changes the shift because if the temperature is increased, it will shift to whichever side the heat is not on. The third example includes pressure and volume. Due to Boyle's law, when the pressure is increased, the volume is decreased. In a balanced equilibrium equation, when this occurs, it means the reaction will shift towards whichever side has the least amount of moles, because there's less space for the reaction. The opposite is also true. If the pressure is decreased, the volume will increase. The reaction will therefore shift to whichever side has the most amount of moles to compensate for the added space.